Well, hello everyone. In this video, we're going to walk through the process of building a virtual 3-axis Cartesian robot inside the RoboDK simulation environment. Our goal is to take a static 3D model from a CAD program and turn it into a working kinematic model that we can program and simulate. So first thing first, we need to prepare the complete assembly of our model. And then we need to separate the part into 4 sections, which is base. This is the stationary foundation of the machine. Everything else will be reference to it. And then we got A1. Will be our first moving part. It is designed to slide along the base. And then we got A2. And this part will move left and right along the y-axis gantry. And then we got carriage or A3. This provides our vertical movement and is where we will eventually attach a tool. And please do make sure on your model it will face upward on Z positive and forward on X positive. And after that, you need to export these 4 components into step files. You just need to click isolate and then export to step file. And I have already exported the 4 parts into step file in this folder, so we can move on into the RoboDK environment. So first thing first, we need to import 4 component. If your design is quite big, then it will take quite some time, so gotta be patient for a bit. Alright, the loading is completed. Now in this software RoboDK, we can change the color of our model by clicking the tools panel and go to the change color, and we will change the color of the spoil part so we can see things clearly. And probably I will change the color for the spindle as well to be black. Right, so to keep our project tidy and set a master coordinate system for the machine, the next step is to group these 4 parts into one reference frame. Just click this icon to add a reference frame, and let's just call it machine reference. Just select the 4 components and drag it to the reference frame. Now we can move our machine easier by using this reference frame, and we can change the position of the reference frame in this panel. Just double click on this icon right here. I just have set everything to 0. Right, now we need to make a base reference. Now in the setup, I will put the base reference on the bottom of the spindle, right on the bottom right here. So click this icon again to add a reference frame, and let's just name it to reference. Right, you can manually move this reference frame to fit on the bottom of the spindle, but we will use a easier technique by using measurement tools. It is on the tools panel, and click on the measure or click shift M, and make sure you turn on the snap on arc center and snap on curve midpoint and edges. Let's just click on this edges right here, and the other one is across the circle. Hold on. As you can see, it did a measurement and make a line right in the middle of the spindle, at bottom of the spindle. Now we will make this line to be a geometry by clicking this button right here. Now it will show up here, and we will use the measurement tool once again to define the exact center position of this line. So to make things easier, we will hide the A3 component first and just click across the line. It will automatically snap on the middle. And let's copy this value and paste it in the tool reference frame right here. And as you can see, it will snap right in the middle. Let's make the A3 component visible once again. As you can see, it is right in the middle, and you can downscale and upscale the size of the axis pointer by pressing minus on your keyboard and plus. Right, we can just delete this geometry right here, and we will model a new mechanism. Click on the utilities panel and choose model mechanism or robot, and then we will choose 3 linear axis. You can either choose this one or the other one, which is 3-axis generic, but make sure to put every value of this degree to be 0. And make sure the reference frame that you put on the bottom of the spindle is facing the right direction. And we will assign each of the components in this panel. And then click update, and it will make a new model based from our 3D model right here, but we can move component of the model by using this panel. But as you can see, some part move way off and collide with the other part, so we need to make a limit. Open the mechanism model once again, and we will set the limit for our model in this section. And you can measure the limit for your model in your CAD software. And then click update once again. And now when you move the components from this panel, it won't exceed the boundaries of geometry. You can just delete this model or hide it. And that's it. Your model can be simulated through the software of RoboDK. You can import a G-code file into this station, and you can simulate your model by following the path from the G-code.
Alright, I'll demonstrate how to provide several targets within the tool's reference. From these targets, a program will then be created. I think I will make 5 targets. This program will be capable of looping, and it will also be able to import G-code. So here we go. Thank you.